Hi, my name is Christine G, and I have gone over this problem before in the video. However, I am going to go over it with there are many ways in statistics sometimes to solve things and in math. So I want to go over a different way to solve this because I think it will be helpful for students. So I am going to take a look at this problem. The average calorie intake for the BU 17 soccer players on Rancho Santa Fe attack was 3,000 calories. So here, I'm going to go down here so I have a lot of room and write up normal distribution curve. So this should be symmetrical and look all perfect and stuff. And here in the middle, I'm told that the average calorie intake is 1,000, so that would be, and then I'm going to do a side-by-side where I also have the standard normal distribution, but this one I am standardizing, so here I'm going to standardize, and when we standardize in the middle, the mean is 0. And then if we go out one to the right, it would be 1 standard deviation, 2 standard deviations, and so on. And then to the left, it would be -1, -2, and so on. Here we have more information. We're told that there is a standard deviation of calories. So what that would mean is if we went out 1 standard deviation to the right, that would be 3,400 calories. All I did was add 400 and go 1 standard deviation up. If I went 1 standard deviation down, that would be 2,600 calories. And then I could go up another standard deviation, and that would be 3,800, and so on. And I could do that on either side. Now, this information is asking what is the Z-score for the players who are eating calories in the 91.3 percentile rank? Well, I know that under the curve to the left, the percent of data here is 50%. And I know all of the data under the curve is equal to 100%. So 100% of the data is under the curve. So 50% is to the left and 50% is to the right. However, I only need to go to 91.15%. So here, that I'm going to go, I already have 50%, but I want to go up to 91.15. So I'm going to add 41.15%, because 50% plus 41.15% will give me the 91.15. So now what I can do is I can find out what my actual Z-score would be at this 91.15% rank. And I can do that by going to my book. And I actually have that. So let me see. So this is the appendix B. Let me shrink it too much. So, and what this tells me is the total area of the normal curve between the Z-score and the mean. Right now, we know that we're looking at the normal distribution, and we are looking at, here is the mean, but 0, and then we want to go out 41.15%. So this is the area between the mean, and this is the area under the curve between the mean and the Z-score that we're looking for. So we're going to look for 41.15% right here. Okay, so now I need to find the z-score associated with that. Well, all I have to do is go over here. This is where the z-scores are. So I'd go down to here, 1.3, and then for the 41.15, go up here. So it would actually be, so it would actually be 1.35. So that would be 1.35. Okay? So hope that makes sense. I found this first, and then I had to go over here across, get to what my z-score is, and then also we count this. Okay, so now that, so I know that my z-score is 1.35, so I'm going to write that here, 1.35. I have that, and I know that over here, when I was calculating and going from 3,000 to 3,400, what I was doing was I was saying, okay, the mean is 3,000 plus 1 standard deviation times 10, and I got, oh, I'm sorry, times 400. That was standard deviation is 400 calories. So 1 times 400, 400 plus 3,000, and I got 3,400. And that was the number that was 1 standard deviation from the mean. Then when I went 2 standard deviations from the mean, I did similarly. 2 times 400 equals, then 2 times 400 is 800 plus 3,000 is 3,800. And then I got this number. Now, if I have 1.35 standard deviations right away from the mean, I know it's going to be between 1 and standard deviation. So it's going to be between these two numbers. And I just do the same type of thing. I say, okay, 3,000 plus 1.35 times the 400. And then what I do is I get out my calculator because I don't know what 1.35 times 400 is. And that is 540, and then I add that to 3,000. So that would be 3,540 calories. So at the 91.15th percentile rank, the soccer player is eating 3,540 calories. Okay. And the z-score at that is 1. So I answered both of these. So I hope this makes sense, and let us know if you have any further questions on this. So there, like I said, there are 2 ways that you can answer this question. This one, you're not really using a formula, so this one is different than the video that I showed, and some students like it better, so I wanted to present it as well. So thanks. Hope this makes sense.